compass and principle. Just a minute, be online. Okay, so in the last class, we discussed about the compass survey, and there are different types of the compass survey, and we have discussed about what you call the principle of compass surveying. So and the traversing, how to take the traverse along with the compass, and we discuss about the elements of prismatic compass. That's called cylindrical metal box, pivot, and magnetic needle, graduated circle, or you can call it as a ring inside the compass, which is this an aluminum graduated ring mark, 0 to 360-degree measure to all possible bearing lines, okay, and also the magnetic needle, and there will be a prism also. So that prism generally we use to read the graduation on a ring exactly in the reading the compass. So, and other than that, there are some the reflecting mirror also, sunglasses. You have seen that. Those things we discussed there, and the most important thing is that adjustment of prismatic compass. How we are going to adjustment, especially when you are fitted with what you call this tripod. How we are going to adjust the prismatic compass, right? And especially the centering, leveling, and focusing. These are the main, adjustment in the especially the prismatic compass. So centering is the most important, which is actually the exactly over the station. Okay, and that exactly is a station that you have to mark it with either with the plumb knob or with a just the tape with the, any the if you take the small stone also you can throw drop it from the center point, that also you can mark it, but the exact the centering will be get it from the plumb knob. Okay, and the levelings. So leveling is the most important. If you are not level it properly, and your readings maybe there will be error. Of course you will get some reading, but that is not an exact reading what you want actually. So then the focusing is the most important when you target the any objects or any the particular the benchmark, or it may be the any object, that should be focused properly, right? And yeah, and then we discuss about the surveyor compass, and yeah, and surveyor compass, and also with there also there is a called centering, leveling, and we have to do with the leveling for all this. And yeah, and we started about the whole circle bearing, right? Whole circle bearing, and quadrangle bearings, that we started in the last class. So in the last end of the sessions, we were about to start this whole circle bearing, right? So let me share the screen now so that we can have the the bearing part. Right. So in the last class, we discussed just then a whole circle bearing, how we are going to take the readings. That is the first thing. And when it comes to the quadrangle bearings, and this is how we are going to take the this is actually the true north, north 27-degree, east, and south 30-degree east. This is how we need to take. This is the first quadrangle, second quadrangle, third and fourth. You know very well this. And also this the bearings or the angle, what we call it as azimuth. Another term we call it as an terminology. We call it as an azimuth. Okay. Generally, the common people they can understand, yeah, bearings, or maybe a whole circle bearing, or it may be a quadrangle bearing. But when it comes to the azimuth, only the surveyor and the geologist can understand. Yeah, what is a azimuth? This is an alignment. This is a direction. This is bearing. Okay, this is all the different terminology we use it for that, right? Right. Then here is the how we are going to the this is here. Both the things are here. They are written here. Quadrangle bearing means, so here they did it. North 27-degree east. This is a quadrangle bearing from here to here. The same thing you can whole circle bearing north 27 degrees. So when it comes to here in the second quadrangle, so from the so north you cannot measure it. You have to measure it with from the south side, because it's in the second quadrant. South 77-degree east. This is a quadrangle bearing readings. This is how you need to take. When it comes to the whole circle bearing, you have to start with the north. Here it is. Right. So 90, this is 90 plus another, what is this? How much is remaining here? That's all together is 103. Right. This is 23. So yeah, 90. Yeah. So this is whole from this, right? And third point is that then when it comes to the next third quadrangle, so here is that south 30-degree western side. This is towards west. Start with the south 10, 20, 30. So here is the 30. This is south 30-degree west. This is a quadrangle. Okay. Now, how you are going to take the quadrangle? So this is a third and fourth quadrangle. How we are going to take some? Again, it is from the north. Okay. So north 20-degree west. So third and fourth with reference to the south, and first and second, that is first and fourth, that is with a reference to north. But when you take the whole circle bearing, that is completely reference to the north. So here you can see this north 27-degree. That's all. That means it has to come here only, not here. It has to come in the first quadrangle, not in the second quadrangle, not in the third quadrangle. Got it? So north 103 degrees. That means it has to come in the second quadrangle. So north 210 degrees. It has to come in the because it's a 180, 0, 90, 180, 270, 360, 360 bar 0. So when it comes to the 210 degrees, that is in the third quadrangle. From here you can measure it 90, 180 and 210, right? So when it comes to the 340 degrees, that is from here 90, 270, 90, 180, 270, and it's a 340, then about to touch with the 360. This is how we need to take the bearings, the directions or azimuth. When you take a traverse, when you take a different types of levelings, fly levelings, or it may be reciprocal levelings, so or it may be when you are measuring or doing the survey, especially for the high-rise pipelines, road alignment, railway track, tunnel alignment, these are the bearings is the most important, right? Without bearing, you don't know where you are going to plot it, which direction. You may get the what you call this length you may get by measuring with the tape or the maybe the chain, but the bearings, the direction, which direction it's going. Okay, that's the most important, right? So generally, what I would explain that. So when there is no directions, proper direction, when there is no destination, proper destinations, you cannot move from one place to other place. Say for example, when you are traveling, especially in the sea, in the ship itself. So you must, and I mean the ship captain or maybe the those who are in charge for the ship, they must heading towards an Andaman Nicobar from the Chennai. Say for example, there should be a proper directions. He has to go with a proper direction with latitude, longitude. Okay, so it will reach exactly for the what is this Andaman Nicobar. Otherwise, if you don't have the target, if you don't have the directions, and it will not reach that place, luckily or unluckily or by mistake also, right? So the same case for your the traveling with the airways. I mean the aeroplane. In the aeroplane also it's the same thing. From here to Bombay, how you are going to travel? By road, without GPS you can traverse by road. But in the air, how you are going to traverse? You must have fixed with the GPS. I mean the latitude, longitude to reach the particular for Bombay, Chennai, Delhi, right, Kolkata. Where you want to go? You fix the first target, fix the the destination with the latitude, longitude, right? So with that, it will there is a certain level of the I mean there is a elevation as per the DGMS or ATC centers, air traffic controls. The flight has to the fly above the ground, maybe the 20,000 feet above the ground, or maybe 25,000, or it may be 30,000, depends on the instruction given from the end, from the particular line. The direction is also most important there. The particular line, particular directions, he cannot go here and there. Particular direction he has to go. That is his road permit, like airways permit. So he cannot move here and there. Okay, otherwise we don't the collision may happens because if you change your direction, there will be another flight may hit your flight. That is a possibility. Same thing happening there. So you need the proper directions. Here we are taking the whole circle bearing, and there also we are taking the same thing, heading towards north 27 degrees, so and so. That is the thing. Then at certain level, I mean certain distance, after certain distance, they are going to change the direction again as per the requirement. This is all about the directions, azimuth, or bearings. This is a thing. Whole things are happening the same thing here, right? So this is a reduced bearings that we discussed there in the studies, right? When the whole circle bearing is converted into quadrangle bearing, it's termed as a reduced bearings. Oh, this is a very typical one. So in the whole circle bearing, you can convert it to the quadrangle bearings. By doing the first quadrangle, it's not a problem. When you go to the second quadrangle, there will be a minus 180 minus whatever the given values, right? This is about the same things, okay? Right. So what we discussed there, I think we're not a sheet here. Yes. Let's go back to the the meridians here. Yes. So what do you mean by meridians, bearings, and magnetic and true bearings, right? And just now we discussed that this is a whole circle bearing systems, okay, and the quadrantal bearing systems, right? This is how the things, and also there will be some the conversion. There is a small problems how we are going to convert the following whole circle bearing to quadrantal bearing. How we are going to say? You are giving in the what you call this whole circle bearing to quadrangle. WCB is a whole circle bearing, 56 degree, 20 minutes. How we are going to convert with the quadrangles? That will be the same. That's in the first quadrangle. So when it comes to the second question, 170 degree, 05 minutes. Okay. So when it comes to the it is 170 means it's the second quadrangle. So what you need? 180 minus 170. So how we are going to write that? South 9 degree 55 minutes. What? East, right? And when it comes to the third one, whole circle bearing is 218 degree 30 minutes. So when it comes to the quadrangle bearings, 218 18 degree 30 minutes minus 180 degree. That equal to south 38 degree 30 minutes western side. Southwest. This is southeast. This is southwest. Okay. This is in second quadrangle. This is in a third quadrant. Right. Now, so WCB whole circle bearing 272 degree 15 minutes. So when it comes to the quadrantal bearing, 360 degree, right? Because it's in the fourth quadrangle. 360 degree minus 272 degree 15 minutes. So all we need to get is here. So north 87 degree 10 minutes western side. So here northeast first quadrangle, south 9 degree 55 minutes, that is in the second quadrangle, and third one is south 38 degree west, right? And here is the fourth quadrant. This is all about how to convert the whole circle bearing to quadrantal bearings, right? And how we are going to take the readings, that's what we discussed in the previous slide, right? Conversion is a very easy, but where it is exactly coming, that you must understand. First quadrangle up to 90, and after that there will be a second, and after the third, and after the fourth, right? And it's in the reverse way. So here what we did, convert the the whole circle bearing to quadrantal. So now convert the quadrantal bearings into whole circle bearings. So in the reverse order here. So not 10 degree east. Whole circle means not 10 degree. That will be there. Whole circle bearings. When it comes to the quadrangle bearings, south 30 degree 14 minutes. That's in the east, right? That is in the first quadrant. So now here is that whole circle bearing 180 minus 30. So you will get 149. Same thing for rest of the quadrangles, right? So what do you mean by reduced bearings? That we just now discussed that. When the whole circle bearing of line exceeds 19 degree, it must be reduced to the corresponding angle less than 90 degree. The value recorded in the quadrant. Okay, this is called as a reduced bearings. Okay, that's how the things. Now, so how we are going to get which is in which quadrant? That's what WCB between 0 to 90. This is called a reduced bearings, and this is a quadrant. Case one is first one, whole circle bearing, reduced bearings, then quadrant bearings, northeast. Second one 90 to 180, that is in the southeast. Okay, 180 minus WCB, whole circle bearing that. So 180 minus 270, that is in reduced bearings. So whole circle bearing, how much it is there? Minus 180 degree. That's in southwest. So like this, 270 minus 360 degree. So this is about 360 minus with the whole circle bearings. That's with the northwest. So all four quadrangles, right? Okay. And what do you mean by fore bearing and back bearings? What do you mean by fore bearings and back bearings? So this is a very simple one, but you must have the clear idea about the measurement of the types. So levelings. Fore bearing is nothing but, I will show you the picture there. Fore bearing means the bearing of line in the direction of progress of the survey is called the fore bearings or forward bearings. The bearing of line in which the direction of the progress of survey, how we are going to progress, that is called your fore bearing, forward type. So backward means, so the bearing of line in the opposite direction, the backward direction, opposite direction of progress of the survey, it's called back bearing, or we can call it as a reverse bearings. Generally, when you fix one station or a point, or locate any of the objects like a culverter, or it may be a benchmark. So when you start with that, okay, when you start with that some point from the 0, you are going to identify or measure the unknown points distance by taking the bearings as well as the distance, the distance. So once you change the instrument from that unknown 0 to back the forward, then you shift the instrument, then you come back. So I mean, you take the back readings, that will confirm you that yes, that is the same one, but that you should not disturb the the first one. So the bearing of line in the opposite direction, that's called the back bearings. The bearing of line is indicated in order to which it is lettered, and A to B is the fore bearing alpha of the line AB, whereas the bearing of AB, line of AB in the direction of B to A, that is back bearings. So here is a very simple concept, you can easily fore bearings and back bearings. So here is that A to B, click it. This is your forward directions. This is how you are going to take the readings first. So when you start from the A and you determine the the distance, some distance at a particular point B, right? You can go back there, right? So once you identify this B point, you change the instruments here, and from here, before taking the next the fore bearings, you must take the back bearings now. What is the angle? For that, this is a angle. Okay, actually fore bearing angle, this is back bearing angle is this. Okay, right? So that you will get the back bearing the angle, right? The same thing you need to convert the first reading. And also just to keep in mind, when you change the instrument, you have to take the back bearing to confirm the back the station, okay, whether it is exactly is there or not. That's called your confirmations, right? Back bearing and fore bearings, right? So here is what is the relationship between the back bearing and fore bearing? Do you really require to take the back bearing? If it is say yes, yeah, that's right. So whole circle systems, if the fore bearing of line is known, that means forward bearing of line is known, then back bearing is equal to fore bearing plus or minus 180. That we have to do that. That's what here is. This is a 180. Right? So here is that case in the quadrangle systems, the fore bearing and back bearings are numerically equal, but there are opposite direction. Forward bearing is the forward, back bearing is the in the reverse way, right? Okay. So how we are going to calculate the calculation of included angles from the bearings, that we'll discuss in the latest class. And yeah, we will do some the problems calculation on this, and it's a very simple problems which you are going to take it. So now we'll go for the bearings are over. So now we are going to take the meridian. What do you mean by the meridian? Meridian, nothing but bearing of line is always measured clockwise with respect to some reference line or direction. This mixed line is known as meridian lines, right? So here is the bearing of line is always measured clockwise with respect to some reference, with respect to north reference, with respect to some field reference, whatever you have there. That is a mixed, and that line we call it as a known meridian. There are three types of meridian. One is magnetic, next one is a true, other one is a third one is a arbitrary meridians. Okay. So here, in this case, magnetic meridians, the direction shown by the freely suspended needle, which is magnetized and balanced properly without influencing any other factor, it's called a magnetic meridians. That means that is a magnetic, maybe 2 or 3 degree variations from the true meridians, right? The true meridian is the line in which the passes through the true north and south, north-south direction. That is the one. Okay, and particularly the line, the direction of true meridian at any point can be determined either by observing of the sun at 12 noon or by the shadow that you can do it true meridians true north. And arbitrary is a very simple one. In case of any small wars or in places where the true meridians cannot be determined, then any direction of prominent object is known to the reference direction. That's what in the field itself, if you have any reference directions, reference mark, or it may be benchmark, that you need to mark it, that you need to take it as a so what is a true meridian? Line or plane passing through the particular, through the geographical north pole and geographical south pole. This is called a magnetic meridian. It's called a magnetic bearing, and this is actually the true meridians to north pole, and this is a true bearings. Okay, that's what this is about the meridians. So when it comes to the magnetic meridian, it is indicated freely suspended. That's what we discuss. Okay, magnetic meridians, right? Arbitrary. So other one we call it as a grid meridians. So sometimes what happens for preparing a map, some state agencies assume several lines parallel to the true meridian for a particular zone, not for all, particular zone. These lines are termed as grid patterns. That is with reference to the some bearings, then only you can do that, right? That is for preparing a map for some state agencies or for several lines with respect to the already established grid meridians, right? That is a one. Whole circle bearing we discussed there so far. What is that? Quadrantal bearing, that is also we discussed there. And if it comes here, northeast, A point, and southeast, B point, southwest, C point, and northwest, fourth quadrangle, first, second, third, fourth. Okay, all right. The conversion of WCB into RB, reduced level, just now we discussed, it's in the table format now. Okay, so WCB between this one, it's a north that we discussed. Same thing, it's in the table format, right? So forward bearing and back bearing also we discussed that. So it is in the different mode. So every line may be defined by two bearings. That's called either by end of the line or by the at the observed. Both bearings for WCB and differ by 180s. It's a four bearings again. So this is a back bearing in the reverse way. Okay, this may be a positive or negative in this case, right? So here is the thing called remembering the the some points. The angle 1 point first, forebearing of line AB and back bearing of line AB here, right? This is a back bearing when you take, and this is a forebearing angles. Okay, that's what. This is forebearing and this is a back bearing. Easily, you can easily understand the things. This is a one point, particular point. From here to here, it may be 100 meter, or it may be 50 meter, or it may be 60 meter. Okay, whatever the requirement, right? That is a one. How we are going to compute the angles, whatever we got there. Okay, so here what we need to do, the observing the bearing of the lines of closed traverse, it is possible to calculate the included angles which can be used to plotting the traverse. When you take the survey, you must take the distance as well as the angles. It's called bearings. Okay? At the station where the two line meets, two angles are formed, and exterior angles and an interior angles, right? So when the stations which are there are two survey lines meeting, that's creates one called two angles we create will create interior and exterior. That's one. These are all the interior one, and exterior will be here, right? The interior lines are included generally in the smaller one. That's one of the things. Here you can see this, right? That's included angle. That's the exterior angles. This is, so we call it as from A angle is a F, that's called. And when it comes to the AB, the angle will be the A dash. This is called an included angle. At station A, this particular place, FB of AB, forebearing of EB and back bearing of EB. Back bearing of EB, forebearing of BB. It's measured. And what would be the difference of these two bearings here? Angle of A, that's equal to forebearing of AB and back bearing of EA minus back bearing of EA. If you know these two bearings and angle of A, you can easily calculate. Right? Same thing here. This is exterior, outside the angle. It's inside them. Okay, and here is that the station of B, FB and FE of BB of AB are used, and there will be a difference between these two bearings. Okay, and this you can easily rectify with exterior angle B and interior angle B. Okay, that's the thing. This we discussed there in the last class, compass surveying, different compass, right? And in the next class, we will discuss the problems which are related to the whole circle bearing, quadrantal bearings, right? It's a very simple problems, so that easily you can solve the problems. It may be the closed traverse is conducted with the 5 stations like this, which DE and which is anti-clockwise direction in order to form a rectangular pentagons. Okay, these things we will discuss here in the next class, right? Let me check this.